Hello everyone, a very warm welcome to Learnwizz. I hope you all are doing really well and आप सबकी पढ़ाई बहुत ही अच्छे से चल रही होगी. So in earlier lectures, we finished trigonometry. We solved many questions in between. We saw the concepts like trigonometric ratios for some particular angles, and trigonometric ratios for complementary angles, and we also saw trigonometric identities. So from today, we are going to start a new series on NCERT exercise solutions. So let's begin with the first exercise, that is 8.1. Let's begin. Here's the first question that is given to us. So what is given? We are given in triangle ABC, that is right angled at B, AB is equal to 24, BC is equal to 7 centimeter, and we have to determine the values of these trigonometric ratios. So let's start. How are we going to start? See, it is always easier to begin with the diagram. Whatever is given in the question, let's make the diagram and mark all the given data in the diagram, and then it will become easier to solve. So here we are given a triangle ABC, that is right angled at B. So let's say this is the triangle ABC. This is the right angle. This is angle A and this is angle C. What is given? AB is 24 centimeter. So this AB, this is 24 centimeter. BC is 7 centimeter. All right. And now we have to calculate these trigonometric ratios. So can we use Pythagoras theorem in this triangle ABC? Of course we can, right? So what is Pythagoras theorem? Pythagoras theorem states that in any right angled triangle, hypotenuse square is equal to perpendicular square plus base square, right? Very nice. So if we consider angle A, what is the base that we are going to have? This 24, this AB, that is going to be our base, and this BC will be perpendicular. All right, and this AC will be hypotenuse, of course, because the side that is opposite to the right angle is always the hypotenuse. Fine. So if we apply this, what are we going to get? AC square equal to BC square plus AB square. Fine. This implies AC square equals 24 square, 24 square plus this 7 square, that is 49. Is that fine? All right. So what is 24 square? Let me tell you a shortcut trick to calculate squares also. See, 24 square will be 576 approximately, but I'll tell you a shortcut trick that is always going to help you in finding squares of any two-digit number. Let's say this 24 is what? AB. Let's say this is of the form AB. What can we write? What is A plus B whole square? It is A square 2AB and B square, right? What is B here? B is 4. So what will be B square? B square will be 16. What is 2AB? 2AB is 2 into 2, 4 times 4, 16. Alright, and what is A square? That is 2 square is 4. What are we going to do? Let's underline the units digit here. This is 6. What is remaining? 1 is remaining, right? So we'll add 1 here. This will give you, again underline the units digit. This is 7. 1 is left, right? Add 1 here. This is 5. So the square, that is 24 square, you will get this underlined digits, that is 576. All right. So this 24 square will become 576. This 49 is here. What is this? this is 625. All right. So what will AC be? AC is square root of 625, that is 25. All right. So now we have got AC, right? Let's change the color once. We have got this 25 centimeters. Now what do we have to calculate? We have to calculate sine A and cos A, and similarly sine C and cos C. Fine. So let's see sine A. Sine A is what? Sine A is perpendicular upon hypotenuse, right? What is perpendicular for A? This 7, right? So this is 7 upon 25. Fine. All right. What about cos A? Cos A is base upon hypotenuse. What is base here? Base is 24. It will be 24 upon hypotenuse, that is 25. Now see, now we have to find sine C, right? So if we consider angle C, if we consider this angle, what will be the perpendicular? See, the side opposite to this angle, that will become our perpendicular. So this will become our perpendicular for angle C, and this will be our base. So what is sine C? It is again perpendicular upon hypotenuse. And what is perpendicular here? 24. So this is 24 and hypotenuse is 25 already. Fine. And what about cos C? Cos C is base upon hypotenuse, and here base is 7. 7 upon hypotenuse 25. Alright. You can also see here that this angle A and angle C are what? They are complementary angles. And we saw for complementary angles, like sine theta is equal to cos of 90 minus theta, right? So if we have sine A, then that will be equal to cos of this 90 minus A, that is angle C. You can verify it from here. Sine A is equal to cos of the complementary angle, that is C, and same goes for these two also. All right, so this will be our answer for the first question. Let's move on to the next one. All right, so in the given figure we have to find tan P minus cot R, where P is this angle and R is this angle. Fine. So again we'll use Pythagoras theorem here. We'll again use Pythagoras theorem to find this QR, that is unknown side. And what is Pythagoras theorem? It is h square equals p square plus b square. Here hypotenuse is 13. So 13 square is what? 169. 169 equals, if we are considering R, then this will be perpendicular, right? Or if we consider P, then this will be perpendicular. So anyhow, this QR will be unknown and this will be one known side among these two. So it will be 12 square, that is 144 plus QR square. Fine. So this implies QR square is what? It is 25. Hence QR will be 5 centimeters. So this QR will be 5. Now if we have to find tan P, how are we going to do it? We will consider angle P, and for this angle the perpendicular will be this and base will be this, right? And what is tan? Tan is always perpendicular upon base, that is P by B. So what will tan B? What will be tan P? Perpendicular, that is 5 upon base, that is 12. This is 5 upon 12. Now what about cot R? So for cot R we have to use we have to consider this angle R, right? And what is perpendicular for this R? The side opposite to the angle, that is this one. This is our perpendicular and this is our base, right? And what is cot? Cot is always base upon perpendicular. So what is base here? Base is 5. Base is 5 and perpendicular is 12. It is 12. So what about tan P minus of cot R? It is nothing but 5 over 12 minus 5 over 12, that is 0. So this will be our answer. Alright, easy tha. So let's move on to the next question. What are we given? If sine A is 3 by 4, we have to find cos A and tan A. So what are we given? The value of sine A, and we have to calculate some other trigonometric ratios. So let's make the triangle. Let's consider this triangle ABC. Let's say this is A, B is the right angle, and C. So A is under consideration here. Fine. We have sine A. For A, this is our perpendicular. This is our perpendicular. This is our base, and this is our hypotenuse, right? So sine A is what? Sine A is perpendicular upon hypotenuse, and it is given 3 over 4. So as I explained in the lectures also, we can consider perpendicular to be 3k, right? Similarly, we can consider h to be 4k. Now we can calculate AB by using Pythagoras theorem, that is AC square equals AB square plus BC square. This implies h is what? 4k. 4k square is what? 16k square. 16k square is base. Base we have to find. That is AB square, and BC is what? Perpendicular square, that is 3k square. And that is nothing but, wait, we have BC perpendicular 4k. Fine. Oh, sorry. We have hypotenuse 4k. That is correct. And we have sorry, and we have this base, that BC is P, that is 3k. All right, hypotenuse we have 4k, and we have to calculate base. All right, that's fine. AB square plus BC square. BC is what? P, that is 9k square. So what is AB square? 16k minus k square minus 9k square, that is 7k square. So what is AB? AB is nothing but root 7k. Continue. We had perpendicular upon hypotenuse, that is 3 upon 4. This is 3, this is 4. All right, so 4 square is 16k square, is 9k square plus b square. That is correct. 7k square. All right, so we got AB also. Fine. Now we have to calculate cos A. So what is cos A? Cos A is B upon H, right? What is B? B we found root 7k. So root 7k upon 4k. This will give you root 7 upon 4. And similarly, we had to calculate tan A. So what is tan A? Tan A is perpendicular upon base. So perpendicular was 3k. Base was root 7k. This would give you 3 over root root 7. Alright, you can also check the solution if it is correct or not. We know that sine square A plus cos square A is 1, right? What did we get? Sine A is 3 upon 4, that is given. So sine square A is 9 over 16. And what about cos square A that we calculated? It is root 7 upon 4. So its square will be 7 upon 16. This will give you 16 over 16, and that is nothing but 1. So the answer is correct. We just checked it out. Fine. So this is finished. We calculated tan A also, and we calculated cos A also. Alright. So now let's move on to the next question. What is it? So here also we are given that 15 cot A is equal to 8. So does it mean cot A is nothing but 8 over 15? It is, right? Now we are not making any diagram. We will try to solve it without the diagram, and we will try to solve it as fast as possible. So we know that cot A is what? Cot is base upon perpendicular. So can we assume base to be 8k and perpendicular to be 15k? That's fine, right? Now we can use the Pythagoras theorem, that is h square equals to p square plus b square. What is it? Equals to 8k square or 15k. 15k square is 225k square plus 8k, that is 64k square. What is it? 289k square. This means your hypotenuse will be 17k. Alright, and we had to calculate sine A and sec A. What is sine A? Sine A is simply perpendicular upon hypotenuse. Perpendicular is 15k, that is given. And hypotenuse we calculated 17k. So this will give you 15 over 17. Alright, now what is left? Now we have to calculate sec A, right? Sec A. Sec A is what? 1 upon cos A, right? And cos A was what? Base upon hypotenuse. So 1 upon cos A will be hypotenuse upon base. What is hypotenuse? 17k. Is it? Yes, of course. And what about base? Base was 8k. So sec A will be equal to 17 upon 8. This will be our answer. Alright. So it is not necessary to draw the diagram and calculate everything from the start. It just depends on the practice. आप जितनी प्रैक्टिस करोगे उतनी इजीली आप क्वेश्चन सॉल्व कर पाओगे बिना किसी डायग्राम के, बिना किसी हेल्प के, एंड कैलकुलेशंस आप अपने माइंड में कर सकते हो. फाइन. So we will develop that approach also. So let's move on to the next question. What is given here? We are given, let's see, we are given that sec theta is 13 over 12, and we have to calculate all other trigonometric ratios. Fine. So sec theta is 13 over 12, and what is sec? We just saw it in the previous question. Sec theta is nothing but hypotenuse upon base, right? We were here. So we saw this was what? Hypotenuse upon base. So now let's come here. Sec theta is what? Hypotenuse upon base. Fine. So can we assume hypotenuse to be 13k and base to be 12k? Now we'll simply use the Pythagoras theorem, that is h square equals to p square plus b square. H square is 13k square, that is 169k square. 169k square equals to p square plus 1 44k square, that is 12k whole square. This is p square is what? 25k square, and this will simply give you perpendicular to be 5k. Alright, now we have to calculate all other trigonometric ratios. So let's start with sine A. Sine theta. Sine theta is what? Perpendicular upon hypotenuse. What is perpendicular? 5k. 5k upon 13k, that is hypotenuse. This will give you nothing but 5 over 13. Alright. Now what do we have to calculate? Cos theta, right? What is cos theta? Cos theta is also 1 upon sec theta. Fine. This is, and sec theta is 13 over 12. So what is cos theta? Cos theta is nothing but 12 over 13. Now what is left? We have to calculate tan theta. Tan theta is what? Perpendicular over base. What is perpendicular? 5k. And what is base? 12k. This is going to give you 5 over 12. Now what about cot A? Let's see cot A. Cot A is nothing but 1 over tan A. This is 12 over 5. Alright. What else is left? We are left with cosec theta. And cosec theta is what? 1 over sine theta. That is this reciprocal of this 5 over 13. That is 13 over 5. Fine. So this will be the answer. We calculated sine, cos, tan, cot, cosec, and sec was already given. So this way we have calculated all the trigonometric ratios. Alright. So let's move on to the next. What are we given? See, if angle A and angle B are acute angles such that cos A is equal to cos B, and we have to show that angle A is equal to angle B, that is the value of angles A and B both are same. Alright, so let's start. This question will start with a diagram. Fine. See, angle A and angle B are acute angles. So if we consider this triangle, so this is an acute angle, this B is an acute angle. So let's say this is C, the right angle. Fine. And what are we given? We are given that cos A is equal to cos B. Fine. So if we consider angle A, what is our perpendicular? The perpendicular, so if we calculate cos A, the perpendicular for A will be BC and the base will be this AC, right? So cos A is what? It is BC upon, that is base upon hypotenuse, and hypotenuse is what? The side opposite to the right angle, that is AB. Fine. Now what is cos B? If we calculate cos B, if we consider this B, then this perpendicular, this AB will be the perpendicular because it is opposite to angle B, and this base BC will be our base. So this will be nothing but see, oh, sorry, I just made a mistake, I guess. See, for angle A, this BC was our perpendicular, this AC was our base, right? So it is not BC, it is AC. All right. And now we'll see cos B, and for B, this is going to be, this AC is going to be our perpendicular, and this BC is going to be our base. So this is what? BC over hypotenuse, that is AB. Now we are given, according to question, we are given that cos A is equal to cos B. So we can say that AC upon AB is equal to what? BC upon AB, right? So we can cancel this AB and AB. This gives you AC is equal to BC. So now we know that this AC is equal to this BC. And in geometry, that is in the triangles chapter, we have studied that angles opposite to equal sides are equal in are equal. That means if in a triangle, let's say PQR, if these two sides are equal, then the angles opposite to them, that is this angle and this angle, they will be equal. Similarly, if in any triangle this and this sides are equal, then the angles opposite this and this, they will be equal. So here we have proved that AC is BC equal to BC. So this clearly means angle A is equal to angle B, and this is what we had to prove. So it is proved. Fine. अब ये result कैसे आया that angles opposite to equal sides are equal? That we'll see in the triangles chapter. But for now, you can assume that this is the result. You can learn this result that angles opposite to the equal sides, that means sides which are equal in length, then those angles will also be equal in measure. Fine. So now let's move on to the next question. Here it is. We are given that cot theta is 7/8. All right, and we have to calculate first this one and second this one, right? So there are two methods. First, we can calculate with the help of this cot theta. We can calculate sine theta and cos theta and put it in this expression. Else, we can also try to simplify it and then evaluate the required trigonometric ratio and put it in that expression. For example, we are given what? 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta, right? So is this of the form a plus b into a minus b, right? It is, right? And a plus b into a minus b is what? It is a square minus b square. So we can write this as 1 minus sine square theta, and this is what? A plus b into a minus b again. So this will become 1 minus square theta. Now we also know that sine square theta plus cos square theta is 1. So does this imply that 1 minus sine square theta is equal to cos square theta? If we bring this sine square theta to the right hand side, we can easily infer this one. So this will be equal to cos square theta upon 1 minus cos square theta. Fine. That is correct, right? All right. Now we can calculate cos theta with the help of this cot theta. So what advantage did we get? Earlier we had to calculate this sine theta also and this cos theta also. But now, since we have already simplified it, we just have to calculate one trigonometric ratio, that is cos square theta. Fine. Now cot theta is given. Cot theta is 7/8, and this is nothing but equal to base upon perpendicular. We'll use the Pythagoras theorem. H square is what? P square plus B square. We will let B 7k and P to be 8k. H square is nothing but 64k square plus 49k square. What is it? 113k square. Fine. What is H? Root 113k, right? What is cos theta? It is base upon hypotenuse. What is base? Base is 7k upon root 113k. This is nothing but 7 upon root 113. What is cos square theta? Cos square theta is 49/8. Now we'll put it in this equation, in this expression. So what is cos square theta? Cos square theta is 49 over 113 by 1 minus cos square theta, that is 1 minus 49 over 113. We'll simplify it. 49 over 113, this will be 113 minus 49 over 113. This will be cancelled out and this will give you 49 over 64, right? Yeah. So you'll get the value to be 49 over 64. This will be your answer. Fine. And the next one is easy. Next one is simply cot square theta. You already have cot theta, so you'll just square it. This will give you 49 over 64. So you can see both of them are equal, right? That means this expression, this particular expression will be equal to cot square theta. Fine. So that is up to you. You have to show, just you can take it as a homework. You will show that cos square theta by 1 minus cos square theta is cot square theta. So this kind of questions we did in trigonometric identities, and similarly you will solve this one. You will prove this one, right? It is easy. If you try to think, it will become easy. Fine. All right. Okay. So let's move on to the next question. Okay. So you are given 3 cot A is 4. This means cot A is 4 over 3. You have to check whether this expression, that is 1 minus tan square A by 1 plus tan square A, is equal to this cos square A minus sin square A or not. And how will you do it? With the help of this cot A, can you calculate tan A? Of course you can, right? Tan A is nothing but 1 over cot A. So tan A will be 3 over 4. Now simply put it in this expression, that is 1 minus tan square A by 1 plus tan square A. 1 minus tan square A upon 1 plus tan square A. What will it give you? 1 minus 9 upon 16 by 1 plus 9 upon 16. If you simplify it, this is what? 16 minus 9, 7 upon 16. Then this is 25. Fine. Now what about cos square A and sin square A? See, this tan A is what? Tan A is nothing but perpendicular upon base. So you can let perpendicular to be 3k and base to be 4k. You can calculate hypotenuse square, that is p square, 9k square plus 16k square. These things should be in your mind. By practice, you will be able to evaluate all these within seconds. So this will be what? H is your 5k. Fine. So what will be sin A? Sin A is perpendicular upon hypotenuse. Perpendicular was 3k by 5k. This is 3 over 5. What about cos A? It is base upon hypotenuse. Wait, this was 3 over 5, right? This is base upon hypotenuse, that is 4k upon 5k. This will be 4 upon 5. Fine. Now what is cos square A minus sin square A? cos square a minus sin square a is 16 upon 25 minus 9 upon 25. This is what? 7 over 25. So you can see these are equal. Hence, we have checked that the value of this expression will be equal to this expression. Alright, we have verified it. Again, this question can also be solved using trigonometric identities. You can manipulate this expression in such a way that you get the expression on the right hand side. You can try it, and if you have any doubt, you can let me know. Fine. So let's move on to the next question now. What is it? You are given that in a triangle ABC, which is right angled at B, tan A, you have given the value of tan A, right? And you have to find the value of these expressions. What are you given? A triangle ABC, ABC that is right angled at B, and this angle is under consideration. First, tan A is what? 1 over root 3. Can you tell me for what value of angle A the tan A is 1 upon root 3? Do you remember? We studied it in trigonometric ratios for particular angles or specific angles. Well, this is nothing but this is equal to tan of 30 degrees. Alright, how? See, we know that tan A is what? Sin A over cos A. Sin 30 is what? Sin 30 is 1 over 2, 1 over 2. Sin 30 degrees is 1 by 2 and cos 30 degrees is root 3 over 2. So what is tan 30? Tan 30 is 1 by 2 over root 3 by 2. This will give you 1 over root 3. Fine. Now it is easy to calculate the values. To put the values in the expression. See, A is 30. What does that mean? That means C will be 60. Right? Angle A you found it to be 30. That means angle C will be 60 degrees. Now what do you have to calculate? You have to first calculate sin A cos C plus of cos A sin C. What is sin A? That is sin 30, 1 by 2. Cos C, that is cos 60. Cos 60 is what? It is again 1 by 2 multiplied by 1 by 2 plus cos A, that is cos 30 is root 3 by 2, and sin C, that is sin 60, that is again root 3 by 2. This is going to give you 1 over 4 plus this is what? 3 over 4, and that is nothing but 4 over 4, that is 1. Fine. Similarly, let's look at the other expression. This is cos A cos C minus sin A sin C. What is cos A? That is cos 30 root 3 by 2. Cos C, that is cos 60 1 over 2 minus sin A, that is sin 30 1 over 2. Sin C, that is sin 60 is root 3 over 2, and you can simply see these will get cancelled out and this will give you 0. So this will be your answer. Alright, I hope everything is clear till now. Okay, now let's move on to the next question. Okay, so the next question is, You are given a triangle PQR that is right angled at Q, and PR plus QR is given to be 25 centimeters and PQ is given to be 5 centimeters, and you have to calculate the values of these trigonometric ratios. Fine. So let's start. We'll start with the diagram. So the triangle under consideration is PQR and it is right angled at Q. So let's say this is P, this is Q, this is R. Fine. Now we are given PQ is 5. This is 5, right? And PR plus QR is nothing but 25. Alright. So what can we say? Can we say that QR is nothing but 25 minus PR? We can say this, right? Let's name this as equation 1. Now, can we use Pythagoras theorem in this triangle? Of course we can, right? So what is Pythagoras theorem? It tells you that PR square is what? PQ square plus QR square. So if we put the values from this equation and this equation in this, what can we get? PR square is what? PQ square. PQ is given 5. So PQ square is what? 25. And QR is what? QR is 25 minus PR. So this whole square, right? Now let's open the bracket. PR square is nothing but 25 plus, that is A minus B whole square. What is A square? That is 25 square is 625 plus PR square and minus 2AB, that is 2 times 25 into PR. It is nothing but 50 PR. Fine. Now this PR and this PR will get cancelled out. So finally you will get 50 PR is what? 650. Fine. I'm bringing this 50 PR. I brought this one to the left hand side and simplified this one. So this 0 and this 0 will be cancelled out and you will get PR finally to be 5 and 13, right? So you will get PR to be 13 centimeters. So you got this 13 centimeters. So what is QR? QR is 25 minus PR, that is 25 minus 13, that will be 12. So this QR will be 12. Alright, easy tha. And what do we have to calculate? We have to calculate sine P, cos P and tan P. So we will be considering this P. What will be the perpendicular? This will be our perpendicular for angle P. This is of course our hypotenuse and this is of course our base. What is sine P? It is nothing but perpendicular upon hypotenuse, that is 12 over 13. What is cos P? Base upon hypotenuse, that is 5, base is 5 and hypotenuse is 13. What about tan P? Tan P is perpendicular upon base, that is 12 over 5. And this is also equal to sine P upon cos P. Sorry, this is P, right? Not A. This can also be calculated using sine P by cos P, that is 13 divided by 5 by 13. That will give you 12 over 5. This will be your answer. Alright, I hope it was clear. So now let's move on to the next question. I think this is, this is our from exercise 8.1. Okay, let's see, what do we have to check? State whether the following are true or false and we have to justify. Fine. So let's see the first. The value of tan A is always less than A. Is it so? Do you think the value of tan A is always less than 1? See, we studied that Sine A and cos A, they are always less than 1. Fine, we studied this, but is it possible that tan A is also always less than 1? So we will try to find some examples, some counter examples that will be going to negate this statement. So what is, let's consider angle 60. We can consider, right? We will have to think. See, for 45 also, if A is 45, what is tan 45? Tan 45 is nothing but 1, right? Tan 45 degrees is 1. It's equal to 1. It is not less than 1. Always less than 1, right? And similarly, tan 60 is what? It is root 3. So this will be again 1 point something, right? 1 point something. So it is getting bigger than 1. That means this statement is false. This is not true, because we were able to find a counter example. Now we'll have to check if sec A can be 12 over 5 or not, right? So if sec A is what? Sec A is 12 by 5. It is what? Sec is what? Hypotenuse upon base, right? That means our hypotenuse is what? 12. Okay, let's say 12k. Hypotenuse is 12k and base is 5k. What will be what will be perpendicular? We will have to use Pythagoras theorem, right? So we will use h square is p square plus b square. That means when we use Pythagoras theorem, we'll get h square is what? P square plus b square, right? And we have h is what? 12, that is 144k square equal to p square plus 25k square. This means p square is this 144 minus 25, right? Is it fine? Yeah, I guess it is fine. So this means p is root 119k. Now if you calculate sine A, if you are calculating sine A, what is sine A? Perpendicular upon hypotenuse. What is perpendicular? This is 119k upon hypotenuse is 12k. Fine. See, this 119 under root 119 will be 10 point something. Fine. And this it will be 10 point something. That means the value, overall value of sine A will be less than 1. It is not going to be greater than 1. That is fine, right? That is fine. And what about cos A? That is b upon h. It is 5k upon 12k, that is 5 over 12, right? 5 over 12. This is also less than 1. What about sine square A plus cos square A? This is just, we are trying to check from all the identities and all the results that we have already known. So we will check them and we will see if the particular value of sec A for this particular value of sec A, any of those results are failing. If none of the results fails, we can say that yes, this is possible. And if any one of the results is failing, then we will say that this particular value of sec A is not possible, right? So what is sine square A plus cos square A? Sine square A is 119 plus 144. What about cos square A? It is 25 upon 144. This is 1. This is satisfied. So, all right. Let's check one more property. What is tan A? Tan A is nothing but sin A upon cos A. Sin A is what? 100 root 119 by 12. This is 5 by 12. Tan A will be root 119 over 5, right? We know that, let's come here, 1 plus tan square A is what? Sec square A. So here what is 1 plus tan square A? 1 plus 119 by 25. This is what? 144 by 25. This will be sec square A. This means sec A is nothing but 12 over 5. So it is satisfied, right? So this is satisfied. So we can say that sec A can be 12 over 5 for some particular value of A. We don't know the value, we can't calculate the value easily, but we know that for in some particular value of A, this particular this 12 over 5 is possible, right? So this will be your true statement. Fine. See, because, and we can also say that since cos A, that is 5 over 12, and sin A, they are not exceeding 1, so they are not violating that result, that is sin A and cos A are less than 1. So hence they will be true. This will be true. Now what is the next one? This is cos A is abbreviation used for cosecant of angle A. So this is of course false, because this cos A is used for cosine. Cos is for cosine, and for cosine, cosecant we have cosec. This is for cosecant. So this is obviously false. Cot A is product of cot and A. Of course it is not true. See, cot A, if we are given cot A, then this doesn't mean cot is something different and A is something different. No, this cot is applied over this A, then we get the value, let's say B over P, right? So when this cot is applied over A, then we get this. It is not that some cot is multiplied with A. That we already saw in the beginning of trigonometry, that sine A and cos A or any trigonometric ratio doesn't mean we are multiplying something. We are not multiplying sine and A or cos or A. We are evaluating the sine, cot, tan, and whatever be the trigonometric ratio of that particular, of that particular angle A. Is it fine? So this is obviously wrong. This is false. Now see this one. Sine theta is 4 over 3. 4 over 3 is what? 1.33, I guess. 3333. Right? So it is greater than 1, but we know that sine theta is always less than 1. So this will be false. Alright. So this was it for the first exercise of trigonometry. In the next lecture, we will solve the other exercises. I will start with exercise 8.2. Till then, keep practicing all the questions from all other various books like R.S. Agarwal or R.D. Sharma or any other relevant book that you have. And if you face any difficulty, you can always post your doubts in the comment section and I will be happy to answer them as soon as possible. So keep watching, keep practicing, keep studying, and stay healthy.